Okay, so here is what I got. So first thing I did is I got this tank model from Sketchfab, brought it into Blender and cut it up into some pieces. So we've got this turret up here, which we'll be able to rotate later once I get to that. But this is going to be the new pawn. It's got the tank script right here. Let's go down this checklist. So the tank does exist. We have a testing environment as seen in here. I have this wall right here to show collision. The game manager singleton you'll see is right up here. Gives us the prefab for the player and the controller. Again, has a spawn point right there. And when we run it, it will set itself to not be destroyed between levels. Yeah. What else we got? Game manager contains up-to-date list of controllers pawns. It should. I believe it does. Here's the variables. It's got the games course. Just the player controller. And I don't have it set to pawn because I don't have a variable for pawn, because if you have the player controller, you can get the pawn. All you have to do is, inside the player inside of the pawn, it will inside the controller will have a pawn that you can get. So I thought it would make it cleaner if there was less variables for like that. And I do have a list for all of the player controllers here, and it adds them to the new list of controllers whenever we make one. Anyways, that's it for that. I made this in this. Whenever you make one, where is it? Yeah, I made this init function, so that when you spawn this tank pawn, or I think this controller, yeah, it just pass some stuff in here to initialize it to make everything work. And there's no key codes because I'm using the input actions. So that's here. So they're not exactly exposed for designers, but they shouldn't be too difficult to change. Inheritance. Yes, they do use inheritance. This pawn right here has functions for setting the throttle to turning and to setting the brake. And inside of the tank pawn, that's also the case. Although we have a few other things like calculate movement. Yeah. What else? Movement, entry point. Yeah, all of them should be exposed. The comments, I do need to go through this and refactor it because it's very messy. But essentially, what's happening is it's calculating the movement and then it's moving the tank every frame. I know you can do it in fixed update, and that should be better, but whenever I put it in a fixed update, it starts moving at like Mach speed. I don't know why. So I'm just going to keep it in update for now. And so when it calculates the movement, all it's doing is it's setting like... This is just a local thing just to make things look cleaner. The brake vector is the opposite vector of where it's currently going. And so the damping is used to just slow the tank down. If just over time it will just slow down so the doesn't go in one space, like one direction forever. The current velocity is just the direction you're going, and it's like the main driver of change. So after you calculate all of the movement and you move the tank, this is literally the entire move tank function. It's just moving it along it's just moving it along the current velocity vector. So other things that this calculate movement does is it has this variable for acceleration and throttle, and basically every single frame that this is called, it's going to be adding the amount of acceleration that it has accrued into the velocity. And these are both vectors, so the vector addition actually works out really nicely. I don't have to do that weird like interpolate between a drift vector and a normal and a movement vector. But this throttle right here for the acceleration, Originally, I have this set as like a buffer because I was going to put some other things in here, but it's actually better for me to just have the throttle and the acceleration be the same thing. So up here, when you set the throttle, this is bound to one of the input actions. It's actually bound to the left stick on the controller, so this is a vector 2, but it's only passing the Y value of the vector 2 because the other one is used for turning. So you have that -1 to 1, and you have like all the decimals in between. These are here just for convenience, so these will help me tell if it's moving or not, or if it's going forward or backwards. I was going to use these for something complicated, but I ended up finding a simpler way to do it, but I'm going to leave these here just in case I need them. But the throttle is literally just the forward vector of the tank times the acceleration amount in the outliner, and then just the input. And then if you're currently braking, you can't throttle. So braking cancels out your throttle. What else happens in this calculated movement? Yeah, it clamps the velocity. So if the velocity is greater than the top speed, which you set in the outliner, it sets it back to that. And I know there's a way to set the magnitude of this. It's just, this is how I thought in my head. Yeah. Turning is simple. We have an actual turn amount, and a lot of the things I'm doing are relatively complicated because I'm using animation curves to have the most control over stuff. So I believe the turn speed curve is your turn speed changes based on how fast you're moving already. So this will be if I can pull this up. Here it is, the turn speed curve. So the X value would be the velocity that your tank is moving in, and the Y value is like a scalar value for how fast you can turn. So the faster you're moving, the slower your turn becomes. So in some cases, you might want to turn really quickly. You might actually want to stop your tank first. I have a bunch of other scalar values. I have this acceleration curve. So you accelerate quickly, and then you start to accelerate slower over time. And then this damping curve, which is probably the most important one, because I was originally going to have it like multiplied by like a different scalar value, but this alone is already like enough, and it has a lot of control you can do in it. And then these are all of the things. So I have the stationary turn power, the damping amount, the acceleration, the top speed. They need to be refactored to make it simpler, but in my head, the top speed is just that, how fast you go. It is actually how fast you're going at top speed. But the acceleration, I want to refactor eventually to be like the number of seconds before you get to top speed. And I was testing around like 3 or 2.5 seconds is really good. And then the damping amount, I'll also change to be the number of seconds you want like the tank to stop. I want it to be like 4 seconds. 4 seconds turn seems to be good. And then the stationary turn speed is self-explanatory. The brake power is 1 right now because it's already pretty damn strong. I'm probably going to divide it by another like 100 inside of the thing so the designers can have more control over it. But for now, this all works. And I'm just going to show it off now. So since I'm on controller, I can slowly move forward, or I can move forward quickly. And as you see, it doesn't go through the wall. And best of all, you can drift. Oh yeah. Actually working so much better than I thought it would. And as you see, once I get up to top speed, it takes a long time to turn. But if I stop the tank, I can turn really quickly. Oh yeah. It's really fun.
think it fell off. Hold up, there it is. So you can do some cool maneuvers, like you can go to full speed, turn, and then like go backwards and stuff. It's kind of like you're on ice, but these controls, like the damping and stuff that I added to it, helps it feel more like friction, and like weighty instead of ice-like. I want to add angular damping, but I need to refactor my code before I can because it's too spaghetti code right now. Oh yeah. Alright, bye-bye.